Hello. Today is about reviewing what we've been doing for the last couple of weeks of trig before we get into our last bit of this year, which is going to be just graphing our sine, cosine, and tangent functions. So I want to just do one or two problems with you and let you work on this so we can go over this. Don't remember, there's no test over any of this. This is just to help you be better at understanding applications of trig. I do have an enrichment for those of you who want to do something more than this. And the enrichment is go in your house or your place where you're living and find an example of an angle of elevation and angle of depression. Example, take a picture of it, and you can make up numbers if you want to, but show us what it is. Okay, so let's start with number 4, okay? This is a bearing problem, which we just had in our previous lesson. Two ships leave the same port at the same time. Ship A travels at a bearing of 40 degrees east of north at 32 miles per hour, and ship B travels at a bearing of 50 degrees east of south at 38 miles per hour. How far apart are the ships after 2.5 hours? Again, the first thing I always like to do is I like to draw my compass. So never eat soggy waffles. Okay, so ship A is in the northeast. So we know that ship A is leaving out of quadrant 1. And ship B is in the southeast. So we know that ship B is leaving out of quadrant 4. Since they leave the same port, we can draw out of the origin angles that are going in this direction. And it's asking for how far apart are they after 2.5 hours. Now, it's hard to see on my drawing here. We know that this angle right here is 40 degrees because this is ship A. And we know that this angle over here is 50 degrees. So what is the angle that must be inside this triangle that makes up here? Well, we know if this is 40, then this has to be 50, and this has to be 40. So that's your right angle right there. So here's ship A, and here's ship B, okay? We want to know how far apart are they after 2.5 hours. Well, we know that ship A is going 32 miles per hour, and ship B is going 38 miles per hour. Okay? So the question is, how far are they? Remember, this is given miles per hour. We need to know the distance. So the first part is we need to know what is A's distance. So we have to do 32 times time, because we know distance equals the rate times time. So 32 times 2.5, because that's 2.5 hours, okay, gives us 80. And then for B, we have 38 times 2.5, which gives us 95, okay? Well, I would probably use Pythagorean theorem here to find now this missing side, because we now know this is 80, and this is 95. So I would do a squared plus b squared equals c squared for this problem. So we are given our legs, and we need to find our hypotenuse. So 80 squared plus 95 squared is going to equal c squared. And when you solve, you should have gotten the distance c to be 124.2 miles. Okay? Okay, now I'm on the other page looking at number 5. So this one says the angle of depression from the top of a 35-meter cliff to a boat on the lake below is 18 degrees. Find the distance of the boat from the base of the cliff. Okay, so let's always draw a picture. So angle of depression means we're coming from above looking down. Okay, so here's my triangle. This means my angle of depression right here has to be 18 degrees because I'm looking down on my line of sight. So this is 18 degrees, that angle. Okay? It says from the top of a 35-meter cliff. So we know right here this is 35 meters, and there's your right angle. So by alternate interior angles, the angle down here must also be 18 degrees. So it wants to know how far is the distance of the boat from the base of the cliff. So that's looking for this distance right here on the ground. Okay? So again, here's our angle that's given. This is the side that's opposite it, and this is the adjacent side. So out of our SOHCAHTOA, we will probably use tangent. Okay? So we're going to say the tangent of 18 equals the opposite, which is 35, divided by the adjacent. So to find the adjacent, multiply both sides by a, get rid of the a here, multiply both sides by a. We know that a times the tangent of 18 equals 35. Okay, so to solve for a, divide both sides by tangent of 18. Okay, cross these off. So make sure your calculator Desmos is in degrees. You're going to get a is equal to 35 over the tangent of 18, which gives you 107.72 meters. Okay? All right. Okay, cross off 13 and 14 unless you want to look at them and look at a video online. Okay, using the unit circle, trying to use a trig value here. But if you want more of a challenge, you can try them. I do have the answers, so I can go over them with you. Okay, let's go here and look at number 10. So we're trying to find two angle measures between 0 and 360 degrees. So this is from our lesson a couple weeks ago. When tangent is equal to -1. So again, think about the unit circle. When is tangent negative? Well, tangent is positive in the first quadrant. There's this phrase that says, all students take calculus, and it's all about when your trig values are positive or negative in the unit circle. All stands for all sine, cosine, and tangent are positive. In the second quadrant, S stands for only sine is positive. So that means in the second quadrant, tangent has to be negative. Okay? Right here. Then, in the third quadrant, that means only tangent's positive. Sine and cosine are negative. And in the fourth quadrant, that means cosine is the only one that's positive. So that means tangent, for our situation, is also negative. So tangent's negative in the second and fourth quadrant. So now we're looking at when is tangent equal to -1? Well, the only time tangent can be equal to 1 ever on the unit circle is when you're at a 45-degree angle. Okay? Why? Because we know at those angles right here of 45 degrees, your ordered pair is square root 2 over 2, comma, square root 2 over 2. And when you do y divided by x, that gives you 1 because they're the same. So we're looking at what angle here in the second quadrant. Right here, this 45 degrees, a reference angle in the second quadrant. And that means that this angle is 135 degrees on the unit circle. And then the angle here in the fourth quadrant, that is our 45-degree reference angle, is really 315 degrees. And there's your answers. Okay, I'm going to give you the rest of the time to work on this review, and we'll go over the answers on the next office hour.